Hello, good afternoon, everybody. How is everybody doing today? Are we having a good VMUG in London? I'm seeing some nods and a hand up. That's always a good start. So for today's session, we're going to be having a bit of a chat today about the vDefend's role in enhancing VMware's security. So to start with, what is vDefend? I'm sure a whole bunch of people are asking, what is this? Has anybody heard of vDefend before? Cool, few nods, few people seem to understand. That's always a good start. So for a bit of background context, vDefend used to be part of the NSX Enterprise Plus setup and used to be able to access all of this stuff from within the NSX Manager's menu. So it used to be included. It's now a bolt-on into the VCF subscription bundle, and they've rebranded everything as vDefend. We love Broadcom. They do love going through a rebrand at the moment. So vDefend is really just the new name for the NSX distributed firewall. You may have heard it also be called. But that focuses around doing security at layer 2 and layer 3, both with the distributed and gateway firewall, but it also does that for virtual machines and containers, all within both overlay and VLAN segments. So it's not just like it's in part of the NSX virtual networking. You can do it in part of VLAN networking as well. And yeah, you may also kind of come across this technology when you look at things like micro-segmentation. So it's not just about splitting things into different VLANs or sort of segmenting it in that sense. You might look at using micro-segmentation for saying that only maybe VMA is allowed to talk to VMB on maybe, let's say, certain ports, just to try and help keep things a bit more secure. So what's the point of vDefend? Because why should we care, right? So traditional firewalls kind of protect your border around an environment. The best analogy I find for this one, explaining it, is a bit like a moat, right? So your traditional firewall, you might have something like a WatchGuard or Palo Alto that sits at the edge of your security on the perimeter, and that protects things from getting on the inside, and that's really great. But what if somebody comes ahead and they get into your environment, right? So that moat doesn't really protect your castle on the inside in terms of how an attacker might be able to move around your environment in that sense. So that's where vDefend comes in. So your castle has a load of rooms in them, and we can kind of think of the analogy here as in your rooms are the virtual machines that you've got in your environment. And by default, you can kind of go wherever you like, and that's how attackers spread around your environment. So if you want to think about maybe what if we put locks on those doors, and maybe we gave each virtual machine or each person wandering around our castle a key card, right? So they can only get into the rooms that they're supposed to get into, instead of getting into rooms that they're not supposed to get into. And that's kind of how vDefend works with the micro-segmentation side. So it's all done policy-based, and we'll dive into a bit of that later. But what we're really doing here is we're saying that only stuff can talk to each other where it's supposed to do, just reducing that attack vector, reducing the odds of people being able to get around. And we can do that in vDefend with stuff like tagging in NSX groups. So we can set up a group that we want to apply a security rule to, and we can set that up based on something like a virtual machine name. So maybe it contains certain things. So you might have a domain controller that's maybe like DC 01, 02, 03, etc. You could have a domain controller group that's got everything in there for like DC as a contains type of thing, so you can do it dynamically like that, or you can apply tags within NSX and have the group filtered based on sort of like a per tag basis. So you get lots of dynamic stuff for it. It's quite nice. It's not a lot of traditional firewalls. You have to go through a bit of effort, like making a group, adding VM entities in and stuff, whereas you can do it quite dynamically with this, which is quite nice. So how does it work? Because it all seems a bit like black magic, right? If we can just kind of lock everything down quite there. So what vDefend does is it functionally puts a little distributed firewall on the VNIC port of all virtual machines. And this is extended to containers as well. So you talk about VCF being all about, multi-workload oriented. So vDefend covers you for all of that. And the firewall actually sits on the VNIC for stuff. And that comes with a couple of really handy kind of bits for it. So you might be sitting there thinking, well, what about my physical infrastructure? How can I segment those type of things off? They're not in the VMware world. VMware hasn't got a clue about those. Because virtual machines have got that firewall on the NIC basis, you can do that segmentation of physical machines if they're talking to VMs or VMs to physical machines, because you've got that distributed firewall is involved somewhere along the chain. You can also do gateway firewalls through service ports, so that's what we've got the lovely little orangey firewall on the gateway firewall there. And you can use that to segment physical servers by basically routing all their traffic through the NSX edge, those posh logical routers you get in NSX, and that allows the distributed firewall to be applied to those. So we can do that sort of stuff. And when we talk about containers, it's not just things like pods that you can run natively on vSphere and VCF. It also includes like VKS clusters and all of the other bits and bats to go through that. So how easy is this to implement? Because it sounds slightly complicated. So here is a list of my lovely, very well-named tags that I have got set up. So I set one up for something like my AVI controller, some for some Cloudflare machines, DMZ servers, all of that stuff. Really, what you want to call it is whatever you want to at the end of the day. You can create those tags from within the NSX user interface under the inventory and then the tag section, and we can define something like that. What we can then do is we can go ahead and create a group, and we can go ahead and spin up a new group and add a criteria to that, and we can go ahead and say throw in our DMZ tag, for example, in this instance, to say apply virtual machines in that sense. So we can easily add that in like so. But what about non-service standard ports, right? So things like DNS, port 53, AD, 389, probably. Anyway, there's loads of well-defined standard ports within NSX that you don't have to stress about for common stuff. NTP is another really good example of one. But there are some applications, particularly if you're looking at stuff like containerizations or even just other apps that use high-level service ports that don't conform to this. So how do we look at getting those in? Well, the services section allows us to easily define new ports based on sort of where we want to come from or go to in terms of source and destination ports. So what you can see there on the side is mine sort of talk about any in terms of source ports, because realistically VMs will come out at any random high-level port, but we can define our own custom ones. So a really good example of that, near the bottom, there's one labeled Formbricks. It's like a Microsoft Formsy self-hosty one, but that uses port 3000, which NSX hasn't got a clue about that, so we can tell it about that, and we can then go and implement rules using those services to sort of define that for how our infrastructure looks, because everybody's is different, right? So the rules. So what we can do is we can create a policy set at the top. So I have a policy called DMZ. Everything in the NSX firewall is applied top-down. That bit's really important, and it's whatever first rule gets hit is what rule gets passed. So if you've got policies above that are dropping packets for certain things, you've got to make sure that it's all layered in the right sort of order, otherwise you may end up with like packets array being dropped out. But we can then add rules to each of those to say allow things to go to and from bits. So I did like a couple of block rules at the bottom, which is kind of a, they can get out to the internet, but they can't talk locally. And that's kind of more your zero trust baseline that microsegmentation is very good for. It's the whole, we're going to block everything, and then we're going to allow stuff on top of that, since the allow rules will get hit first. If we don't match any of those allow rules, then it will go ahead and hit the block rules, and our traffic stays nice and isolated. So in my DMZ example, stuff is only talking into here on ports that I really want it to, because it's got like my web server in it, and I don't really want that being compromised, for example, because my infrastructure is really important and my website is on the internet, for instance. So we can set that up like so. Container workloads. This is a little bit different with VCF 9 if you particularly do the containerization with the new VPCs introduced in NSX 9, but just kind of pulling away from that for a second and looking at a bit more the standard size for vSphere pods and Kubernetes clusters. What you'll find is that on the left side of that, we've got all of our namespaces that were created within vSphere. And what you'll find is that vDefend automatically layers those rules on to drop packets by default. So there's a denial ingress rule that stops packets coming in. Services can still get out, which is what we'd want them to be able to do. And that keeps all of our namespaces isolated in the container workloads as well, so that we're getting that microsegmentation where we want. And those rules are layered on by default. You don't actually have to put those in. The Kubernetes side will take care of all that for you. You can layer additional rules on top of that if you want to, but you get a nice, good baseline. So it kind of keeps you covered. So what we're going to do is we're going to have a little look at a demo. So we're going to hope that my live demo works nice and good today, and that the VMware gods have blessed me, touch wood. So what are we going to go through? So I've talked through how to do a lot of this stuff, but we're actually going to have a look at it, right? So you can all listen to me talk and look at stuff online, but let's actually get stuck in. So what have we got? I've got a web server that I'm running in a little VMUG demo segment, and I've got a Windows machine that I'm accessing that web server over, and I want to look at isolating those bits out using the vDefend firewall as a bit of a demonstration of how we can do that. So we're going to go through creating tags. We're going to look at creating some services. I won't need any for mine, since we're just using default HTTP for the website, since it's in a lab, and that's a well-defined port service within NSX. Don't worry, we can search for those, and we'll cover that. And then we'll go through creating groups. We'll look at creating policies and rules so that we can actually start applying those firewall filterings to it. And then we'll look at, we can also enable logging and how that ties in with the other VCF portfolio stuff, like the operations for logs piece that, anybody used operations for logs? Hands up, a few people. It's really good, and we can suck in all those firewall logs straight into VCF Ops for logs. So those are quite important things that we can look to enable. We'll look to block or allow certain services. So we'll be looking at SSH and HTTP, since that's what's mainly configured. You might want SSH allowed into certain services from maybe a certain group or a jump server that's allowed to do those type of things. And we'll actually have a look at the quick rollback feature, which is a really nice one. Nothing sucks more than making a real big change on a firewall, for instance, and then you kind of go, I can't get into my server anymore, and you're all sat there panicking because some server's in a DMZ and you've now just locked yourself out of it, and everyone's sort of having a bit of a kerfuffle with it. So the firewall vDefend supports the quick rollback feature, so you can view each changes you've made in a draft, you can view the draft, view the changes, and you can do a nice quick rollback to sort of go, I'd like to Control Z do all that as you sort of, blunder it out. Righty-ho. That was the video on this side. So now I need to figure out how to get out of here. Can I? Right, I think that is copying this. Bear with my laptop while it has a slight moment. Where did it go? So, let's get NSX logged in as well. I'm losing my tabs. I need to actually close tabs off. So, to start with, we'll have a look under these security tabs. So, question is, where is all this stuff? So, vDefend, all of the stuff's interacted from within NSX. You can add your standalone vDefend license keys into NSX directly, so that makes life quite a bit easier. It's not quite handled with the new single keyless design with VCF9s. You've still got to add the manual keys in, but you get nice for that. Everything generally is handled under the security tab, so that's where I can start making configuration changes, looking at my firewall. There's loads of other security features that are included with other bits that we're not going to cover quite today, but this is generally where I'll be looking at things. And the main bit I'm bothered about is going to be that distributed firewall. So before we start putting rules in place, the best place to have a look at is actually getting our sort of groups, our tags, services, and stuff defined so that I can actually start making rules, right? Because there's no point in me putting a rule in if I can't actually tell it what to apply it to. So we can find that under the inventory tab at the top of the NSX menu. And then what we can do is we'll start with tags. I like VM tagging. You can do it based on VM name. You can do it based on IP address. There's about 100 ways to skin the proverbial cat of how do I actually filter my servers out. So you can do it based on how it works best for you and your organization. So adding a tag is as simple as coming under the inventory section, coming into tags, and then clicking add tag. And then we can call it a name. So we will call this one, let's go with VMUG web servers. You can see browser keeps caching everything as I go ahead and do this demo many times beforehand. So we've got our management server. That's what's going to be connecting into our web server as our filtering demo. And then we're going to go ahead and click select virtual machines. So I need to tell it what VM should we be tagged with this for. So in this case, I'm actually going to search for the VMUG machines because I have prefixed them all with VMUG. And we're going to go find our management machine, and we're going to go and select that and apply that tag to it. And then hit save. And we can rinse and repeat the same process again. So we'll do the same for the web servers. So again, give it a name, select the virtual machine, prefix all the VMUG stuff, and we'll go and set up our web servers here. So now we've got our tags, and NSX9 has introduced this massive kerfuffle of tags, which is really unhelpful. So thankfully, we have a lovely search feature, so we can go ahead and find our tags. So if I search for the VMUG group, we can see our new tag groups, and then if we click the little 1 under assigned to, we can just go and double check our VMs. Yeah, they are in there. That's great. Everything's being pulled up, and that's good to see. So that's pulled in. Lovely. We talked about services in terms of defining sort of, I say standard ports, but, not the very well-defined stuff, usually somewhere in the first sort of 1,000 ports, those kind of services. So if we want to add a service, it's as simple as it's still in inventory, under services, and we can click add service. I'm just going to do this one as a demo for HTTP. You can substitute this in for whatever ports or whatever service that you've got. So we'll do this one. VMUG HTTP. HTTP is well defined, and we'll show you how to filter and search for those as well. In case you're asking the question of, well, is my thing well defined? I actually have no idea, so we'll cover that in a second. We can set service entries, and we can add a new one. So if I just call this one again, VMUG HTTP. Service type, we want to go for TCP traffic. Source ports, we typically don't care about. Most machines will use any high-level service port for any outbound traffic, and it's usually random, so we don't really care about that. What we care about is the destination port, so that's where am I going. So HTTP has the default port of 80, so that's what I'm going to throw in under my destination ports. It's a checkbox, so you can throw in multiple ports. If you have a service like Veeam, for instance, that's using a whole bunch of different ports for, say, connecting up to ESX and vCenter, where you might want to have one service for your kind of vSphere connectivity. You can add multiple ports in there, like you might do 902 and 443, for example, for Veeam. So you can do multiple bits here. It's quite customizable. We can apply that and save it, and then that that service will be available for us to sort of pick and choose when we want to set rules. So what if we want to check if something exists? We have the search filter, so that was over on the right. Click filter by name. The really important bit that we can actually do is we can click on the bottom here. We've got enter destination ports, so that's what am I connecting into. And if I go ahead and fill in 80, for instance, in here, this will show me all the services that have port 80 defined somewhere within them. So if you're wondering if your service exists, that's a really great way to sort of, tick through and have a look and kind of go, well, you don't want a bunch of duplicate entries for something like HTTP for everything if, we've already got a default one. So that's an example of how you can do that. Heading over to setting up our groups. This is really helpful if we've got multiple virtual machines. Again, NSX9 has added all these lovely GeoIP systems, so we're going to be making heavy use of the search feature. But we can add a new group, so that's from inventory, groups, and then add group. We can go and call this. So again, I'll call this one VMUG management servers because the group's kind of the same for this one. And then we'll set a compute member. So this is where I can add my criteria. And this is the question of, well, what is actually going to be in this group and how do I want to define what it looks like? So the IP addresses tab lets you put in IP addresses or subnets if you want something that's maybe a bit more akin to maybe more traditional firewall, or maybe you just prefer to manage things on a per IP basis. You've got that functionality. It's not you've got to use the tags. But we can also use membership criteria, and this helps us to get a really dynamic feel for how we're going to be adding and moving machines into it. Since I don't need to edit groups using a dynamic criteria, I can use a tag, I can just tag a new VM, or I can do it based on names. We get a whole bunch of different criteria. So you can do this based on NSX segments and other bits. We're going to be sticking with virtual machines for the case of this, and we're going to be using the default tag equals, and then we're going to go and select our tag from this. So this one was for the management servers, so we're going to use the management server tag. And from there, this will pick up the group with that definition on it. You can add additional conditions, so you can add as an AND rule. Maybe you want a VM to have 2 tags or more. You can do a tag and a name. You can do OS types and computer names. You've got equals as an option, but you can also do things like contains, starts with, for example. A really good example of that, I think, was my load balancer. They're all prefixed with the same name, so I can just define a group that sort of says, if it starts with this or if it contains this, then put it in the group, and that makes it a bit more dynamic for me. In the case of Avi, which is my load balancer of choice for this, it's always creating new load balancers, so using tagging doesn't work, right? If it makes a new one, it's not auto-tagged. So we've got those kind of options, and we can add multiple criteria. And in this case, we can do ands or ors, but typically you'd be looking at or. So if it's criteria 1 or criteria 2, then it gets thrown in the group. So there's loads of customization with it. But we'll go ahead and click apply, and then we'll click save again. So I'm going to repeat for the web servers. So VMUG web. Helps if I can type. And again, same principle. We'll set another compute member. We'll add our criteria, and it's again virtual machine tag. And in this case, we're going to be opting for the web servers, and we can click apply. So to check that that's all been applied properly, we can again make use of our really lovely search feature, which is coming in nice and handy at the moment. And if we again search for VMUG, and we go ahead and check that, we can see that our 2 new groups have in fact been created. And if we click under the View Members section, we can see that those VMs have been pulled in. And the really important bit that we also want to make sure is that the IP addresses section is filled in as well. So it's pulled the IP address straight from there. Did learn this one the hard way. If you happen to change the IP profiles in NSX and you don't include whichever the checkbox is called to pull IP addresses from vSphere, it won't pull this IP address, and then all your firewall rules magically don't work, and you end up pulling your hair out working why it doesn't work. So, but it'll automatically pull the virtual machines, the IP addresses, any segment ports, anything it's bound to, and anything like that. So nice and easy, take care of that automatically. So now we've kind of got our baseline set up, so we've got everything that we need. Now we can start thinking about, right, how do we secure, how do we lock stuff down? So this is where we can head back to that security tab, and we're going to be looking at the distributed firewall. I'm going to go ahead and click Add Policy, and we'll call this one, I don't know, VMUG Demo, right, because we're just demoing it for you guys. We can expand that, and then we can go ahead and we can add a rule. So the question is, what do we actually want this rule to do? And this will depend on entirely what your organization wants that firewall to do. So usually a good start is blocking some form of ingress or egress traffic, depending on how you want it doing. And that's more to keep in line with micro-segmentation practices, and that really only what should be communicating is what should need to be communicating. But for the purpose of this, we'll be blocking SSH to start with. So just to show that everything works, we'll pull open the management box, which I think has locked itself. Yes, it has. So if we go ahead and pull that in here, and we just crack open a terminal session, We do SSH, try and go into my username for the web server. So that was VMUG web 01. And that will get me logged in, for example. So we've not done anything, and I can SSH to my Ubuntu server, which is hosting my web server, right? Everything seems pretty normal. So we'll log out of that. And now we'll start actually locking that down. So let's say perhaps this machine's not a jump box or isn't a machine that should be doing SSH connections. So let's block it and see if we can actually prevent this from getting SSH access. This one's quite important. You know, SSH is a really critical attack vector. If someone's in your environment, they're going to be trying stuff like SSH and RDP, and they become really important. So let's add a rule to block SSH. So our source, so we need to think about where is the traffic actually coming from. So in the instance of this, we're going to be looking at those management servers on our VMUG group. So we're going to just make this a bit bigger. Add in our management servers, that's where our traffic's coming from. Our destination, so where's the traffic ending up? I want to block stuff from SSHing to my web server, so that's definitely going to be my destination in this case. So we'll go ahead and throw the web servers in here. Services, so if we leave it on any, it's just going to do it for everything. We're actually only really interested in blocking port 22. Again, SSH is a defined port, so we don't have to worry about adding a service for it, but if I search for SSH, we should find it. We can still use the same filters that we went over before in terms of destination port. If you're not entirely sure what it's called, sometimes they're called something different than you might expect, so you can do both. We can select SSH. Context profiles we can leave alone, same for the applied to, we want that on the distributed firewall. And then what we can do is we can change the status. So we get three options. We can allow the traffic through, which is what we already see. That's kind of the default. We can drop the packets, or we can reject the packets. I probably wouldn't use reject. So the difference between a reject and a drop is a reject actually sends a notification back to the client device to say that traffic's dropped. So for example, if you choose to drop IMCP or ping traffic to a machine, then kind of just looks like the VM's disappeared off the network, right? The ping just sort of dies. If you do reject, you end up getting a notification back on your ping terminal to actually say that the client has actively refused the packet. So from an attacker's perspective, they kind of still know you've got something on the other side, which defeats half the point. So in this case, we're just going to drop the traffic. And the last thing we're going to do is we're going to click the little gear icon. And over here, we're going to go ahead and we're going to enable logging. So by enabling logging, that means all of the packet rule hits or misses go through into the ESX log directories. And if we have VCF operations for logs pulled into an environment, then they all get sucked into that, and we can search for and filter things, which is really helpful when you create a firewall rule that you end up pulling your hair out because you've broken it and you can't figure out why you've broken it. And then once we've created our rule, we get this lovely little ID. So the ID is really helpful for troubleshooting because anything that's hitting this rule is going to have the ID tag baked into it. So you want to filter for it, then that ID would be great. So if we go ahead and we just refresh that rule, we'll make sure that this is a success. And so hopefully, unless the demo does me dirty, if I try and SSH back into this, yeah, it's not asking me for my password, and that traffic's being dropped out by the firewall. And these VMs are all on the same layer 2 segment in NSX. Doesn't matter if it's a VLAN segment on the physical network or it's an overlay virtual segment. We can do that at layer 2, which is one of the really big advantages of the vDefend firewall, something you can't achieve with a traditional firewall. You know, if you want to block it, you've got to spin out another interface, do another VLAN, and put the rules that go across that. So this is great. I've managed to block it. That's amazing. Good start. We have a look at the website. It's a very basic WordPress website that just says VMUG demo on it, and I can get to that in a web browser, nice and easy. So let's go ahead and block that as another example. So we'll just do this one to block HTTP. And if you're doing multiple rules, you can actually drag the groups from one into another like this, so I don't have to go through the search menu each time. It's a really handy little feature, so I can drag those over. Again, services, we'll go ahead, we'll find HTTP in here. It doesn't chop my keyboards off. So I end up having a few now in here. So we can find standard HTTP. Go ahead and apply that. And we can go ahead and drop that traffic too. So we're going to refresh that. Perfect, that's a success. Now, if I go and reopen this and I try and get somewhere, all I kind of get is the spinning wheel of death at the top of it. So we can see that HTTP traffic is kind of now dropped. But let's say maybe I applied this to the wrong set of servers and I've gone and done myself dirty now and I've managed to absolutely brick my website out. Nothing can get to it. My website's down. I'm having a panic moment. What about that quick undo that we mentioned in NSX? So what we can do is we can come under the Save Draft section and we can have a look at everything that's been pushed in here, and we can see this lovely little object that has a creation time of about 2:34, which is when we were making changes. We can kind of go, okay, well, this is what was done. So if we view the details on those policy changes, we can get an idea of, well, what did I just change? And it shows me in here that what I've done is I've actually modified and added this block HTTP rule, so I can very clearly see exactly what I've done that's caused me a problem. And what I can do at the bottom is there's this lovely, really convenient load button. and I can go ahead and load that configuration back into the firewall, which, as you can see now, has actually removed that rule from the distributed firewall, which is great. And now if I go and refresh my web page, it just says optimistically hoping that NSX will pick it up. Pretty please. Do not click publish. Ah, see, a live demo always gets me. Publish your firewall rules. That's caught me out many a times as well. But yes, the website's now back up and running, so that's what you've got that quick rollback feature for. Make sure you click publish. Don't do a Leaha. But yeah, that's pretty much how vDefend works. Of course, it can do loads more than that. As a quick example, I use it for my DMZ, and there is a whole shed load of rules in here. So the sky really is the limit in terms of what you can do, and you get loads of customization with it. So that brings us to about 4 minutes left. So does anybody have any questions or anything they're just kind of curious about? Nope, silence seems not necessarily a bad sign. In which case, I will pop the last slide of the presentation back on. So we did the Q&A. But yes, we work for Phoenix Software. Get the blip there. We work for Phoenix Software. We do this kind of stuff for professional services. So if you've got any interest in that, whether it's demos, getting help for that, we've got you covered for it. Don't worry. And if you want to know anything more and want to approach me about it, I'm on the stand literally over there on the other side of the wall with my lovely demo on the great big TV. So if you want to see something a bit more in person, come shout. I'm friendly. I don't bite, I promise. Otherwise, I will leave you all to have a lovely rest of your day, because that's everything I had planned for today.